Good morning, everybody who's joined us bang on time. We're just going to hold off for about a minute to let more people join, and then we'll get this webinar underway. So just please bear with us for a little while longer. Okay, a few more people have joined us, so we'll get this event underway. Welcome to this latest in the series of webinars conducted at UKBIC. Today we have a first in that it's the first webinar where we're co-presenting it with one of our valued customers, and today it's our colleagues and friends at Ilika. We will be talking about the work that we've been doing together, but if I could just do a little bit of procedural stuff. To ask questions, please use the Q&A function on Teams, and we'll get through as many questions as we can at the end of the event. If you do want to contact us after the event, you can contact us through the sales at UKBIC, info at UKBIC, or if you're a potential supplier to us, please use the suppliers at ukbic.co.uk email address. But alternatively, if you want to contact Ilika, please email to info@ilika.com. And just lastly, a copy of the slides and the recording will be available via both UKBIC's and Ilika's websites from tomorrow. So without further ado, what we'd like to talk to you about today is enabling solid state battery scale up. And this is a journey that UKBIC together with Ilika have been on for quite some time now. So to start with, we'll just present a little bit of background on both our companies, and then we'll talk about the collaboration. And we'll start by introducing Ilika. So I'm going to hand over to Denis Pasero, who will be presenting alongside me today. So Denis.
Thank you, Andrew, and hello everyone. I'm Denis Pasero, Product Commercialisation Manager at Ilika. So yes, I'm going to introduce Ilika first. The next slide, Andrew.
Not the right slide. Hasn't it moved?
No.
Okay, Denis, I think you've got the slide.
Yeah, I can't see a different slide, but if you can see it. Can you guys see my slide, the Ilika introduction slide?
We can see the Who is Ilika slide, yeah.
Okay. All right. So first introducing Ilika quickly. We are based in Southampton. We're about 65 employees, and we've been in existence for about 20 years now. And we develop solid state cells. In fact, we have two product lines. Stereax is a millimeter scale solid state battery smaller than the nail on my little finger, which we've licensed to an American company called Certec, and these batteries will be powering implantable medical devices. But today I'll be talking about Goliath, which is the development program for cells for automotive and defense applications. So the difference between lithium-ion and solid state lies in the replacement of the liquid electrolyte by, well, simply a non-liquid set of materials, simply speaking. There are nuances in the chemistries. People use oxide, polymers, sulfides. The chemistry we've focused on collaborating with UKBIC concerns a oxide separator. So the solid state chemistry provides some performance and safety benefits, which we can see particularly at pack level. The chemistry enables a simplification of the cooling system, removal of some of the physical protections, all in all, gain weight and make the vehicle more performing better. So we are currently optimizing a 10 amp hour prototype, which will be followed by a 50 amp hour pouch cell. Next slide, please. Okay, so this slide and this graphic illustrates our roadmap in terms of scaling up. So our mission is to develop a new product from our R&D labs and demonstrate it at pilot scale level on industrially relevant equipment to be licensed to an automotive OEM, tier 1 or battery manufacturers, which will then take on the scale up to high volume. But the most frequently asked question regards scaling up. And the question is, will manufacturing solid state batteries, particularly Ilikas, will this need brand new equipment, new processes, very specific solid state lines? And this is exactly why we've been collaborating with UKBIC to answer those questions and de-risk the scale up. And we'll tell you more in the following slide. Andrew.
Thanks, Denis. Okay, so a little bit of background for those who aren't aware of what UKBIC is. UKBIC is the scale-up arm of what is now the Battery Innovation Programme, which is run under the jurisdiction of the Department of Business and Trade. And when we scale up from early stage TRL or early stage material development, and we can take product right through into series production. We do everything in the battery manufacturing process, from mixing, coating, drying, slitting, cell assembly, formation agent test. And then we also have facilities to assist companies with module and pack development. We have a very comprehensive battery development laboratory, and we also have a training arm. In terms of the electrode lines, we have two of them. We have the industrial scale-up line, which is a giga-scale plant, and we now have the newly commissioned and newly launched, as of the beginning of this year, flexible pilot line for earlier stage material development. Now, UKBIC is based in the West Midlands, and we are open to all organisations in the UK who are looking to scale battery technologies. If you're outside the UK, we will also talk to you and see how we can make you fit within our facility and within our remit in terms of enhancing the UK's battery manufacturing infrastructure. One very important part about UKBIC, and one of the things that makes us quite unique, is that we don't want to own any IP. So when you come with your background IP and we jointly develop it into something really special, and there is foreground IP coming out of that, at the end of any project, we hand all that IP back to you, the customer. There's never any question of a license fee or a royalty payment or license agreement or anything like that. Okay, Denis.
Okay, so what we're going to do is describe 3 collaborative programs between Ilika and UKBIC. All 3 were grant funded by the APC, the Advanced Propulsion Center. And the first one is BOS 100. Well, actually, there was some background to this program. We previously collaborated with Comau, which are the industrialization company in the Fiat group. And they carried out a paper exercise comparing our manufacturing process with conventional lithium-ion battery process, and concluded that 70% were about of the equipment used for lithium-ion could use for solid state. So we then collaborated with UKBIC and started a feasibility study where we asked the simple question: what would it take to install an hypothetical 100 megawatt-hour solid-state line at UKBIC? Tell us about the equipment, the economics. How would that work? The learnings were very useful and more detailed than the Comau collaboration. Clearly, a lot of the equipment could be used, equipment already at UKBIC, industrial equipment, but they asked us to take care and think more thoroughly about assembly and the coating of the oxide material I mentioned above. And so we took that forward, and Andrew is going to tell you how that worked.
Okay, so the first thing that we did as part of the collaboration was looked at the existing UKBIC equipment and then looked at what would be required to actually manufacture solid-state batteries at the 100 megawatt scale. From that, we produced a gap analysis of what additional equipment would need to be brought in to enable that production to take place here. From that, we developed the feasibility plan that you saw, which established that, yes, it was indeed possible to install such a facility at UKBIC. And then we did a cost analysis of what that additional equipment would cost in the build, and from that we were able to assess whether it was actually feasible, economically feasible, to build such a plant. And through all of that, we were doing health, safety, and environmental assessments to ensure that the plant that we were planning was going to be safe to use. It wasn't going to have any adverse effects on the environment, and it wasn't going to adversely affect the overall running of the rest of the UKBIC facility. Denis.
Okay. The second project today is System. So System was a direct follow-up from the BOSS 100 project, but moved from the feasibility study to physical trials. And we asked UKBIC to try, and they managed to coat our oxide materials using their industrial equipment. Well, as I just said, this was very successful. The coating worked. In fact, we used the deposited materials, included them in some of our patch cells back at Ilika, created some cells, early 50 amp hour prototypes, and found that they worked even better than the ones we'd made ourselves on our own pilot line. So this gave us a lot of confidence for the future that we could, using industrial equipment, make and optimize those cells. Andrew.
So from UKBIC's perspective, the project was really about understanding Ilika's technology. So from the day one of the project was a substantial amount of time and effort in technology transfer from Ilika to UKBIC to understand what the material was, what its properties were, and what was going to be required in the attempt to do the first coating, which was going to be using the industrial scale-up line. We had to design and get manufactured product-specific equipment which was required to modify the line to run what was an extremely thin electrolyte layer on top of an existing anode material. Fundamentally, that came down to manufacturing a new slot die, which was installed onto the line. And in the last couple of months of the project, as Denis said, we successfully conducted that first trial. In fact, it actually went a lot better than we actually imagined that it would. When we pushed the button, we weren't quite sure what was going to happen for the first pass. We were expecting that perhaps there'd be the odd hiccup, but it just worked. And it was a tremendous endorsement of how the preparation that Ilika and UKBIC had done to make the product led to it working first time. Denis.
Yes, and the third and last project for today is Project Primed. Well, actually, this project is ongoing. It hasn't finished yet. And the intention for this project is to follow on from the system project and now become more specific, more detailed. We asked the UKBIC to give us a set of instructions which enabled us and them to optimize the coating in order to optimize the cell in the long term. So one physical trial on UKBIC's flexible production line has already taken place, and the project, as I said, is ongoing. But what we really wanted here is get the Goliath technology as near as possible to full industrialization. And I think we're getting there. Just pointing out that we are collaborating in this program with HSSMI, the industrialization consultancy, and they are building a digital twin of what a solid-state battery line would look like. And again, this is the information that we will take on when we aim to license the technology to high volume. And finally, we are steered and supported in this program by Professor Paul Shearing at the University of Oxford and SafeBat, and also by JLR. Andrew.
Okay, so UKBIC for this project utilized the flexible pilot line. The main reason for this was that it was actually available and it was commissioned, which it wasn't quite there when we did the system project. So we utilized it, the flexible pilot line. This was one of the very first projects that we ran on the flexible pilot line. And we're doing 2 runs for this. And as Denis said, this is an ongoing project. We've done the first run, which has proven that the process works, that the material still works, and that the flexible pilot line is suitable for the manufacture. And we will shortly be running the next batch of product, which is and the aim is to provide 1 kilometer of coated electrode, which will be used in production cells or production intent cells by Ilika. So those are the 3 projects that we've done. So they all link together. They all run through the TRL scales, Buzz 100, System, and Primed. It's a fantastic example of somebody coming to UKBIC and using us for exactly the purpose that we were built, to enable organizations to come with their early stage technology and scale it up to something that is production ready. I'm sure that the journey with Ilika is going to continue into the future, and that the first production cells could well be manufactured here. Working with Ilika has also really helped us to understand the use of the equipment, and it's also been very useful in testing and challenging our people in adapting to produce different products than perhaps than the standard lithium ion. The current Ilika project is, as I said, one of the first on the FPL. And now I'll hand over to Denis for his conclusion.
Yes, so I can and I will very much echo what Andrew said. Working with UKBIC has been very important and fruitful for a company like Ilika to understand how our emerging technology can be de-risked and pushed for nearer to commercialization and production. And I'll point out two things. Yes, in terms of equipment, the UKBIC have the exact equipment that we needed, from the flexible pilot line, which allowed us to tweak some of the parameters to get better coating, to their industrial production line, which really allows us to understand how that would work at giga scale. The second point are the people. UKBIC people are very easy to work with. They are good teachers and experts in the field, and they've really helped us understand how to de-risk our technology, to be flexible, and working with UKBIC hopefully will carry on in the future. So it's been very positive. Okay.
So that concludes the webinar part of the session, and we'd now like to open up the floor to anybody who wants to ask questions. We do have a couple of questions that have come in already. First one I'll direct to Denis, and that is, when will solid state batteries be commercially available?
Well, that's a good question. In fact, some solid state batteries are available now. A French manufacturer called Blue Solutions were first to produce solid state cells. Their technology, however, requested that the cells be kept at a temperature of 50, 60 degrees. So this is a use case that is relevant for shared ownership buses. And I know that they are now developing Gen 4 for cells that have a wider use case. There are a few Chinese manufacturers who are very near or just about commercializing as well. A brand of solid state called Semi-Solid, which actually already still incorporates some liquid. So the advantages are lesser than those expected for technologies like the Goliath technology from that Ilika is developing. So when will this come to market? Everybody in this sector, including Ilika, is very much in the pilot scale level at this moment. And as I explained on our roadmap earlier, the next step is to then transfer the technology to larger factories. So that can take a small number of years.
Okay, we have another question from early on, aimed at UKBIC, so I'll take this one, and that is, how is the flexible pilot line providing additional support to battery developers compared to the industrial scale-up line? And again, this is an excellent question. When UKBIC first opened, we opened with a gigascale line because we assumed that that's where the market was headed and that people would be looking to scale up immediately up to thousands of cells. So we installed a facility that is that requires a lot of material to prime it and to set it up and to run it. So it actually generates in early stages quite a lot of waste. So to be and it also takes quite a long time to set it up and clean it down again after each run. The flexible pilot line requires far less amounts of materials. We can mix slurries in much smaller quantities. We can coat on narrower foils, so we can altogether produce electrode which is suitable for earlier stage product development. Okay, I've got another one for you here, Denis. Compared with cheaper competitors like Chinese suppliers, what is our advantages if we do solid state batteries in the UK or Europe?
Yeah, that's a very good question. As I explained in my previous answer, some Chinese developers are putting some semi-solid liquid-containing cells to the market. And in fact, no OEM is going to take on this emerging technology just based on the name, solid state. And what they really want to understand is what are the benefits in terms of pack and vehicle design, including cost. So it really is a balance between the offer from a superior solid state technology versus semi-solid. The second point in terms of cost is that the lithium-ion batteries that you could get currently have been developed and manufactured at gigascale. So with the economies of scale, that technology is now at a very low price. There is no reason for solid state technology to be at a different price point to lithium ion eventually. In fact, a few years ago, not long ago, in fact, Bloomberg, New Energy published a report forecasting the price of solid state batteries, and there would be parity, but that parity of price will really only happen when solid state batteries are developed at the same volume, at gigascale level. At that stage, there will be price parity. Now, comparing UK, Europe, and China, it's clear that China is currently dominating the lithium-ion LFP, particular lithium-ion world, and wanted to go to market early with a semi-solid solution. I think what the UK and EU can do is provide the quality, provide the additional benefits of a improved solid state version of solid state.
Hey, thanks, Denis. I've got another question, which I don't know. I think maybe both of us might have a crack at this one, but I'll go first. So the question is, what challenges did you face regarding electrode manufacturing, especially the mixing of slurries for the solid state battery? What are the differences compared to the usual active material for lithium-ion batteries? Well, from a UKBIC perspective, our task here has to be to mix and coat the solid state electrolyte, and we mix it and then coat it onto a standard anode. The mixing process had a lot of challenges, and as I said, when we were talking about the system project, we spent a lot of time in the early stages of the project doing the technology transfer to make sure that the mixers were set up properly for producing a solid state electrolyte, which, as the question implies, is a different product to a standard lithium-ion slurry. So the viscosities are different. We were using a different coat weight. The coating that we were depositing was much thinner than we would normally do on a lithium-ion anode or indeed cathode. So that was really the difference and some of the challenges that we had to overcome from our side. I don't know if, Denis, you've got anything to add from the coating that you've been doing at Ilika?
Well, it's clear that this is a different technology where quite a large proportion of the processes and materials are very similar to lithium ion. By the way, we use high nickel cathodes in electrode deposited, coated in the normal way. We use high silicon anode, same thing here. So yes, there are some differences relying in the coating that Andrew just mentioned, and some challenges, but this is exactly why we wanted to collaborate with UKBIC. We wanted to de-risk and find what those challenges were initially and solve them and provide our licenses with a solution that has been proven, and like I said, this has worked very well.
Okay, thanks, Denis. Okay, another one for you now. How solid are solid-state batteries, and does it matter how solid they are?
Yes, that's a good question. I mentioned already that semi-solid, solid like technology from China are not fully solid. Again, it doesn't matter. An OEM is really wanting to understand what the benefits are, whatever the chemistry is. And so at Ilika, we have we developed a product which in use is solid. You could split the cell and no liquid would come out. But again, what really matters is what happened. What does that safety improvement mean in terms of simplifying the pack? What does the performance mean? And so, yes, that is the important point.
Thank you. I think possibly the last one here, and this is from somebody who's been paying attention to our news feeds. The question is, when will the planned FPL flexible pilot line cell assembly facilities come on stream, and what will they be capable of producing? So thank you for the question, because we are progressing very well with the development of this facility. As I look through the window from where I'm presenting now, a lot of the cell assembly equipment is here, and it's being taken piece by piece through into the dedicated areas within the flexible pilot line where it will be set up. The intention is that it will be commercially available and commissioned by or during October of this year. When it's in, we will have the capability to manufacture a variety of cylindrical cells from 21700s, and we'll be able to do a tabless version of that. We'll be able to do 18650s, and then we'll also be able to do 46XX, whatever that XX is. On the pouch side, we will have the ability to produce a pouch which is around half the size of the one that we currently produce on the industrial scale-up line. So it'll be nearer to 150 to 80 by 10 mil thick. So it's a big step forward. We'll be able to produce in lower quantities, and again, providing a better and more flexible and cost-effective solution for people who are looking to assemble cells. So thank you for that. I think that is, sorry?
Another question.
Oh, sorry.
Slow.
Where's, oh, beg your pardon. Yes, I've just got another question. Thanks for the presentation. At UKBIC, have you had opportunities to work on multiple types of SSBs and components, e.g. ceramics, polymers, semi-solid gels? If so, do you face challenges working between the different formats? We are working with a couple of suppliers on different polymers, but not necessarily with regard to solid state batteries. Ilika is really the UK pioneer for this technology. So our work has really been with them. At the moment, we have conversations with other manufacturers, but we haven't had any sort of actual contract with them yet. So it's a great question. Ask us another again in 6 months and the answer might be slightly different. But yeah, thank you for that. Okay. So yeah, if you'd like any more information on UKBIC, we can send you a link to the UKBIC brochure. That will give you the full range of our capabilities. And I think if that's all the questions, we can now I'll just move on to the final slide, which is to introduce the next webinar that we're hosting, which is not too far away on the 27th of May. And this is the webinar on reducing embossing in electrode calendaring via localized induction heating. As some of you may know, that are involved in the manufacturing of batteries, calendaring presents some fairly unique challenges, and Grace Kimberly Scoos will be introducing you to one of the ways that we are trying to overcome some of those challenges. So please make a note of that and register, and we look forward to seeing you there. Next up, we have our Head of Business Development, Yaya Alvar, who will be speaking at the AABC conference in May between the 17th and 20th. Well, he's actually presenting on Wednesday, the 20th of May, and he'll be talking more about the lessons learned in battery manufacturing scale-up, because there's a lot more than calendaring that are involved in that. So if you're going to be at that event, then I do heartily recommend that you go and have a listen to Yaya. So finally, I'd like to thank you on behalf of Denis and myself for attending today. It's been a well-attended webinar. Hope you've all enjoyed it. If you've got any follow-ups, then you have the details. And as we mentioned at the beginning, the presentation will be available on our websites from tomorrow. So thank you very much for your attention.
Thank you.